Hello and welcome to another Solana tutorial. Today I have something fun in store. I have a little hacker challenge for you. Here's what I'm gonna do. I'm gonna vibe code a program and then I'm gonna let you find the bugs and exploit that program. And then I'm gonna hack the program just to make sure that it's actually hackable. And then I'm gonna let an AI find the bugs and see if the AI could exploit that program. Maybe when I vibe code it, there are gonna be bugs in there from the beginning, or maybe I might add some myself, such that there is something to exploit. But that part I won't show you, because that's the fun part to figure out. So yeah, today we're just gonna have a little fun with Anchor and Claude Code and see how good it is at writing Solana programs and finding bugs in Solana programs. And really, this is about you thinking for yourself and understanding what's happening in order to not make the same mistakes when you write your own programs. So on the one hand, this is a video about vibe coding. On the other hand, this is a video about security. And really, I just wanna have fun. And it just wanna have fun. And I hope you do too. So let's get started and write a program. Which program are we gonna write? My idea is we're gonna do a Flashloan program. Yes, that's what we're gonna do. A Flashloan, by the way, is when a transaction borrows some funds, usually it's a large amount of funds, but it repays those funds within the same transaction. So before and after the transaction, the funds look the same. They're in the same accounts. But during the transaction, we have access to a large amount of funds. That's a flash loan. And flash loans have been used to exploit programs and stuff, or just do trading better because you need some capital for arbitrage or whatever. And so today I want to be the flash loan provider. I will have a program where you can borrow some funds if you repay them in the same transaction. And why would I be doing this? Well, I'm gonna take a fee with every flash loan, and so I make money, right? That's the goal. I'm not actually gonna build a production program. I'm gonna build a hackable program because the latter is way more difficult. But this is for training purposes. That's why I'm vibe coding it. So yeah, let's get started and vibe code ourselves a flash loan program. Let's go. What I'm gonna do is I'm gonna use Anchor in version 1, and I'm just gonna init an Anchor program because Anchor is safe, right? Anchor does a lot of security checks, so the chance that we're getting something wrong there is hopefully somewhat low. So we're gonna Anchor init a flash loan program. Let's go. And then we're gonna open this. Here we go. If we have a keys folder, maybe ignore that for Git. And we're gonna grind a flash. There we go. Flash loss. Yeah, I like it. It has loss in it. Flash loan program that might make a loss. We will see. And then I need an oligarch. Okay, we have 10 sol. It's not that much, but it's enough for a program. Good. Now for the actual program. I said I'm gonna vibe code this. So let's vibe code this. I'm gonna put you here. This is a Solana Anchor program. There we go. I let it just read what we currently have, and then we will get started. Okay, so we'll build a flash loan program. It should store funds in a PDA, and it should have two instructions, one's a loan and one's a repay. At every loan instruction, we make sure that a corresponding repay instruction is also in the same transaction, and the repay checks that all the sol was repaid, and otherwise it fails the transaction. We take a fee of 0.01 sol for each loan. That's the short description of what I want to have. Let's see if/how Claude Code can implement this. Because I'm just lazy. I'm just going to vibe code this. What could possibly go wrong? Many things. But that's what I'm looking for today. I want things to go wrong, such that we have something to hack. It's cooking. Let's see what it's cooking. Needs to decipher my things. Mussing, whatever that is. Generating. Let's see. I think those are just words that it keeps rotating through. Manifesting. Yes, manifest the code for me. Yeah, it's taking some time, but we'll get there. It's a complicated program. If it gets it in one go, I'm gonna be very impressed. Wow, it even understood that I want a flash loan program even before I told it. I didn't even read this. And it suggests we should have a borrow and a repay, fee logic and fee collection. We'll say what it elucidates. Shimming, shimmy, shimmy, shimmy. Doing, yes, please do something. And it's shimming it again. Vibing. Yeah, let's go. It even suggested that we support liquidity providers, which is usually how you would do it, but I'm just going to be an oligarch and just provide some SOL in this case. I want to keep it simple with my flash loss program. Envisioning. Let's see what you envision. Noodling. Oh god, it's noodling and it's processing. Sure it is. You know, I could go have a break while it's marinating my code. Booping? What the hell are you doing? Pursuing. Okay, no, perusing? Pondering. Yeah, it's something to ponder about. Flubber, but whatever that is. Yes, considering sounds reasonable. And shimmy again. Oh, we're doing something. It's thinking now. Okay. So, we're gonna add something to constants. The Flashloan fee and the vault seed. That makes sense, and it's removing the anchor constant because we don't need that. Accept that, okay. Then we're adding some custom messages. Ooh, this is good. Transaction must include flash repay and must include flash loan instruction. Insufficient funds in vault, arithmetic overflow. Cool, sounds reasonable. We are gonna have a vault that just stores the bump and the SOL inside the Lampert's field. So data-wise, we don't need to store much except for the bump for convenience. That also seems reasonable. And we're gonna add those two instructions, flash loan and flash repay. And we're gonna write those instructions. Well, first we change the initialize to storing the bump in this PDA. So we're gonna make it a program-owned account actually with this PDA. We could also use the PDA just as a system program account, but it decided that it wants to create some extra state for the program, which fair enough, let's do that. But I will still manually need to top it up with some SOL, I guess. The Vault PDA is initialized once. And then the flash loan. Oh, now here we have the interesting part. Why does it calculate the discriminator manually? But okay, we take the Vault. We take the borrow as an unchecked account. Sure, that's safe. And the instructions sysvar. Ah, it's smart. Claude is smart. We need to check the instructions. Nice, it's checking that it's the sysvar ID. That's nice. And in the actual instruction, that's why it needs a discriminator, because it checks the instructions for the other instruction. Oh yeah, that makes sense. Okay, if it finds a repay, great. Otherwise it says missing repay. And then we check if we have enough Lamperts to transfer the amount that we want to borrow. And then we actually send from the vault to the borrower this amount. What could possibly go wrong? Let's go. That seems like a good flash loan function. Let's go. Let's see what the repay does. So we once again have the discriminator of the other function. We again have the vault, the borrow, the instruction sysvar, and the system program this time, because we will need to do a transfer. And the handler will find the flash loan instruction. If multiple exist, the last one wins. Each transaction should have a loan repay pair. Encodes instruction arguments as little endian Borsche after 8-byte discriminator. So the loan amount it gets from the instruction in the same transaction, that's smart. And then it checks that it has that, and that the repay amount is the loan amount plus the flash loan fee with a checked add, so we don't have overflows here either. And then we transfer the loan plus our fee back to our vault. Okay, that seems legit. Are we done? Nope, we still need to add those instructions here. Yep, great. Are we done? Check compilation of the program. Yeah, sure, check if that compiles. Exit code 101. Can I do that myself? Can I try and compile it? No, you fix it yourself. Can I just do anchor build? Can I just see what anchor build does? Oh, program ID mismatch. Oh, my bad. I need to copy the FS to my target deploy flash loan key pair, and then I can anchor build. What are you trying to do here now? JSON load, print version packages. No, let me fix that for you. The user doesn't want to proceed with this tool. I don't. I got this. I know how to build an anchor program. You just write the code. Mismatch types. There we go. Expected pub key found account info. Okay, so we are getting errors. Well, then I'm gonna tell you, if you want to build the program, use anchor build. There we go. Anchor build. Yes, you can have that. I could have scrolled up and seen what's not happening. Doesn't like the hash. I could hard code those things. I could tell it to use a different discriminator. Why am I making it so difficult? Why do you need to use that hash? Where are you using that hash anyway? In here. There's gonna be a lot of things to fix here still. I mean, the overall thing looked good, but we have a lot of type errors and stuff. So this is gonna be difficult. Python 3, what does that do? It gets me the discriminators. It just calculates the discriminators real fast. Are you gonna hard code them now? That's a smart idea. Let's hard code them. Sure, why not? More compute efficient anyway. Clouding. Did it just say clouding? Why is it booping all the time? Boop, boop. Okay, what are we doing? Okay, we're gonna add Solana instructions sysvar, which makes sense, I allow that. And we're gonna add the discriminators hard-coded. That's a great idea. I could also use other discriminators. And then we're gonna use those specifically like this. Yeah, why not? There's probably a good reason for that. Okay, what are we doing now? We remove the hashing, which you shouldn't do on chain. That's just useless burning of compute unit. And we're gonna load those from constants. I approve. It's gonna do the same thing for the other file. There we go, as expected. And then, what is it changing here? Oh, because it doesn't import everything. It takes it individually like this. That's fine, okay. Should still do the same thing. And then it wants to anchor build again. Let me anchor build again. We only have one more error, and that's could not find client accounts instruction. Okay, yeah, unresolved import crate. The program macro needs the account. Wait, what did you say? No, tell me what you just said. The program macro needs the account structs directly in scope. So you redo it again. You need them directly in scope. Okay, sure. Let's do it like that again. And then you want to build again. Let me see. A similar path exists. Unresolved import. Still unresolved import. Are you gonna change the rest back now again as well? Spelunking. So what are we changing here now? Crate. Oh, I don't know if that will fix anything, but I'll let you do it. Sure. And then we can import everything again, changing it back. Okay. And change all of that again. Okay. Build again. What would we say? It builds. Yes. I'll let it build once before I let it run here. Oh, for the test, it's compiling the tests. For the tests, it's missing the pair and stuff. But that's okay. We don't need tests. Pfft, who needs tests? Program completed. Only error was in a test file, which is old. Let me update it. Yeah. Fix it for me. Let's go. Then we also have a test. Booping. Why does it still want to change something? It wants the anchor preload pub key and not Solana pub key. Sure. Oh, it was in a test. There we go. Release and test post succeed. Sure, also run the cargo test if you want. Booging. But anchor build is successful now. Okay, let's see. All tests pass. The program is complete and working. Here's a summary. The initialize, so this thing, creates the vault PDA and stores the bump. Must be called once before a loan can be taken. Great. And then probably we also need to put some funds onto that PDA for people to actually be able to take loans. Then loan scans forward in the instructions and fails if no flash repay is found, and then transfers amount from the vault to the borrower, and the flash repay checks backward for the instruction for the loan and then repays the loan with the fees. Security properties. Atomically enforced by instruction introspection. A loan with no matching repay in the same transaction fails at the loan step. A repay called without a loan fails at the repay step. The repaid amount is exact from the on-chain load instruction, not a parameter that the borrower supplies. So this is safe. Super safe. Nothing can go wrong here, right? 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 I mean, I guess so. AI wrote it. Must be safe. So now we can put on our hacker hats and try and hack this thing. And let's see what AI says how we can hack this. But before we get there, let's analyze it ourselves. I'm gonna commit this. While that's thinking, you go check out the code and see if you can think of an exploit how you could get those funds. How you could screw my program. I'm gonna think about it as well. And if I don't come up with anything, I'm gonna add a bug. Okay, so spoilers. Yes, there is a critical vulnerability that allows draining the vault. But before I show you this, I want you to be able to drain my vault. And also before I show myself this, I'm gonna attempt to drain the vault. Because that's the whole fun part. I don't want AI to take the fun part. It can do the boring part of the writing the program or whatever, but I want to hack it myself. Yeah, just wants to reiterate, AI is great and all, but it shouldn't take over all of the thinking that we do. Because first of all, it's less fun if we don't think and just put it all in AI. But also it's just too easy to let AI do everything and then just be like, yeah, I trust it. But hey, if I wouldn't have asked specifically, is there an attack vector, then the AI would make me believe that that's all secure, which obviously it isn't. But we don't even know if it isn't. Maybe AI is wrong with that critical vulnerability. We'll see. I'm not even going to look at it. I want to see it myself. I want to check it myself. And for that, I need to deploy this program. And ideally, I'll also have Kodama running. You know what? New session. I'm going to get you the code from last time. And I'm going to pnpmi Kodama and Kodama nodes from Anchor. Change that name. Yeah, I just let it do its spelunking. Again, I'm getting lazy now that I have AI in here. Sussing. Pontificate. And generate me that code, please. This is doing so much on my machine that I almost don't like it anymore. I really gotta trust that AI to not do weird shit. But it has full access to the CLI, so it's like, fuck. If that thing's after me, that thing can ruin me. Just saying. Okay, how are we looking? Enchanting, yes. Enchant the NPM and just bake it. Oh man. You think I'm faster if I do it myself? Probably not. There we go, I can just run it myself. Why are you taking so long? It's done. Stop it. What are you doing? No, stop it. I'm already done. Yeah. So we have our generated code. We need to add the Solana kit. Let me do that. Kit. And then we should be able to get those instructions. I'm also gonna create an exploit script. And I'm gonna borrow the code from sending a transaction from last time. And from in here, we should get the Flashloan instruction and the get repay instruction. My key is this one. I'm gonna just use the same. It doesn't really matter. I don't need a separate key for exploiting. It's fine. I'm just gonna exploit my own program. Oh, first, before I can exploit, I probably initialize with a get initialize instruction, which needs the payer and the vault. And the vault, how would we get that? PDAs, vault, find vault PDA. So the vault is await this from the generated code, and it could take the program address, but it doesn't even need to, so that should be even fine. Then we have an address and the bump. I'm not caring about the bump. Let's go. And that should do the initialize. So before we can do that, we need to deploy the program though. So anchor build one more time, just to be sure, and then anchor deploy. And that's an anchor v1 program, so it's somewhat big. Oi, too many requests. Failed to initialize IDL. That's fine, I'm just interested in a program and that got deployed. This program is now on chain. Which means I can say initialize. There we go. We sent the transaction to initialize this account, which doesn't have much sol now. So this is my vault treasury thingy. And for the loaning to actually work, it needs some funds. So I'm just gonna manually Solana transfer to this address. I don't know, how much do I have? I had 10 sol. I'm gonna put 8 sol there. There we go. Now if we check that account, it has 8 sol plus some rent. So we can borrow 8 sol. Like for a flash loan, this is not much. In the real world, this would hopefully be more, provided by different liquidity providers. But for today, this is good enough. We have 8 sol that we can flash loan and potentially lose to an attacker, because our vibe-coded program might be vulnerable to some attacks. So let's see. And obviously here I would first suggest that you try it yourself, deploy it yourself, or use the one that I deployed. I don't know if I will still change it. We'll see. But somebody else might have already drained it. So it's better to deploy it yourself again, just to make sure that you have that version, or deploy it locally. It doesn't matter. It's just a simple program. And then check for yourself how you can exploit this. Like, think about it. What's the attack vector? And then actually write the code to exploit it. Or tell AI to write the code to exploit it. But think about it yourself. That's the fun part. Don't miss the fun part. This is now the actual fun part where it's like, okay, so what can we do? But again, first try it yourself and then watch me attempt to hack my own program. So I think our best guess, I mean, the loaning, this is how we get out the funds, right? So our first attempt could be, can we somehow call the loan instruction? And now you're watching me, how I would try to exploit this. Like, this is my hacker brain now. My first attempt would be to see, can I just call the loan instruction without doing the repay? That would be the easiest. But it does this thing with the instruction sysvar. So I'm not sure if I can go about this. And even before I attempt to exploit this, the first thing I would really do is just to use it normally, just to make sure that I know how it's used. So maybe let's do that. Maybe let's do a regular loan, or just get a loan instruction, get Flashloan instruction, just to see what we need here. We need the amount. Let's just borrow 1 sol. We need the borrower, which is gonna be my payer here. And we need the vault, which is gonna be the same that we initialized here, that we can import from the generated code. Borrower needs to be just an address. Let's go. Good. And then we do the repay instruction. Get flash repay with the same borrower and the same vault. Oh, the borrower here needs to be a signer. Oh yeah, because we need to pay back from the payer. Okay, sure. Let's just see. And then we put the loan and the repay in here. And in between, we could do stuff like, oh, look how much sol I have right now. I could write a whole program that prints me how much sol I have on that account or whatever. Should we do that? Nah. So let's see if we could loan something regularly. This looks fine. Transaction confirmed. We call the loan instruction and then the repay instruction that does the transfer back. And in the end, it just looks like I pay fees to the vault account because that's the Flashloan fee that we defined that we repay here. Okay. So it works. Well, do we even know that it works then? No, because we didn't check anything in here. What could I do inside here? Is there a program that logs me my current balance? Could quickly write one. I could even add it as an instruction to my program or let AI write that real quick. And this is just for debugging. I'm not going to use this as part of the exploit. So it's just an unchecked account and we read the Lampert's field of it. Yeah, let's go. Cool. Anchor deploy. Ooh, I have insufficient funds. Ah, I need to hack my program. Oh no, I put too much on the account. Now I can't even deploy the Anchor program anymore. Damn it. Cross fingers for some airdrop. No. Anchor is just too expensive. Well, I guess we gotta hack our program. But I want to demonstrate that this works. I still have funds from last time. Okay, try again. Good. No, not good. Account data too small. Oh. Solana program extend additional bytes. How much bigger did my program get? It's now 200 kilobytes. Holy shit. I don't know, just add, 50. Have insufficient Lamperts again? That account currently has data size 177. Oh yeah, Anchor programs are just ridiculously expensive. So for that one additional instruction, I'm paying another full sol or what? And now? There we go. Should be better. But I'm broke again. Too broke to deploy. Anchor. I'm really looking forward to Anchor V2 because that's gonna make that so much more cheap. Even for DevNet, this is expensive. Says the guy who just put 8 sol into an account. Account not large enough. Still? Okay, get another 10k and then deploy. How am I so broke? Close buffers again. There we go. But now I should have enough. Great. Thank you. Okay, that was more complicated than I thought. But now we just run that generation script again. And then we should have a get log balance instruction that should just take one account. And I'm gonna give you the payer account. And then I'm gonna add this log instruction here in the middle between the loan and the repay. And then I'm gonna run the script again. And this time, there we go. So, what? Did I just accidentally hack this program? It seems so. I didn't even want to. That's the best hacks. You didn't even want to hack the program, but you did. I just drained 1 sol. Basically, I paid the fee, but I drained the sol because there seems to be a bug. I didn't even want to do that. Wait, what am I doing? I'm twice calling the Flashloan. I'm not calling the log, I'm calling the Flashloan. Wait. I didn't even want to do this. Wow. Yeah, let's not do this. The log instruction we put here. So the log instruction, let's pretend this never happened. And we transfer it back. Cool. Never happened. Okay. So now we're doing loan log repay. Let's run this. And again, it looks like we're just paying the fee. And in the end, we still have 3.3 sol. But in the middle, in between, we had 4.3 sol. There we go. And if we would loan a bit more, not 1 sol, but say 7 sol, there we go, then in between we would have 10 sol, even though on our account, in the end, it's again still just 3. Okay, so it works. The flash loaning works. Now let's get to the exploit of this. To the exploit. So my first attempt would be, can I just do the loan without the repay? I shouldn't. Yeah, I'm getting the transaction must include a flash repay instruction. Because in the flash loan, we are checking that we found a repay. Can we somehow have that instruction be called but do something else? So can I somehow mock this discriminator is now my thoughts? Like, can I make it think that that instruction is called when it's actually not called? No, I don't think I have a way around this. Okay, let's look at the repay. So it's checking that the loan amount is present and that it gets from those bytes with the loan discriminator. Well, but here it should be fairly obvious that this is not particularly safe what we're doing. If multiple exists, the last one wins. Each transaction should have one loan repay pair. That's bad assumptions. That's very bad. That's like comically bad even. Because obviously that means that I can just loan twice and repay once. Because the loan just checks that there is one. But then if I have 2 loan transactions, then, I mean, look, that's an easy drain, which you probably figured out yourself as well. So exploit, let's do 1 loan, 1 repay, and another loan. Let's first do a loan big and then do a loan small. So first I loan the entire 8 sol and then I loan 1 Lampert and I put in first the big loan, then the small loan, and then I repay. Which this repay should just repay the small loan and the big loan I should be able to keep. Let's exploit this. There we go. Easy. Plus 8 sol for me. We're back to 11. Nice. Because I can flash loan twice and just repay once. So that's clearly not safe. But you probably realized that. And you managed to exploit that program. Didn't you? I guess you did. But now, back to you. I think you would have warned me about this if I would have listened. Yeah. Critical vulnerability. Multiple flash loan plus single repay. How it works, attacker builds a transaction. Yeah, that's what we did. So the fix would be to ensure 1 loan per transaction. Yes. Please implement this fix. Implement this fix. You get what I mean. Multiple loans not allowed. And now we're scanning all instructions and reject if there is another flash repay after this one. Yeah, seems like a fix. Let's go. Fixed it. All safe now. Right? Right? Yeah, please build it. You have no idea how safe this is. Clean build. An attacker can no longer bundle multiple flash loan calls. Second one is rejected. Great. So with this built and deployed, I have enough salt to deploy now. Don't tell me. Just drained the entire vault. Now my exploit script should not work anymore. There we go. Now we're getting the multiple loans are not allowed. Excellent. So now this program is safe, right? I would say no, but it's because I know Solana and how stuff works. Should we ask the AI what it thinks? But no, I'm gonna first ask you what you think. Do you think it's safe? Will you manage to exploit this? Wait, I'm gonna git exploit fixed. Hack this. I'm gonna commit this. And this is the version, it's Git, you see all the versions. But this is the version that I'm gonna upload to GitHub now. Hack this flash loan. Cool. I pushed it to here. And now you can hack this. Oh, you have my exploits and my generated code as well. Yeah. So this link will be in the description below. And that's the version that I want you to hack. This should be safe now, right? Come on. We can't do 2 flash loans. We checked that. We checked that there must be a repay and there can't be another flash loan. So how could you possibly still hack this? That's your challenge. There you go. So do check out the repo, read the source code, don't look at the git commit history, and don't look on chain. And also don't use AI. Those are all forms of cheating. You want to do it yourself. Try to exploit that program. It is definitely exploitable because I added the bug. That's why you shouldn't check out the history. But even if you did, it's not that obvious. So it should still be a challenge. So yeah. Now is the time where you pause the video and you actually do the thing. And if you manage, great job. If you didn't manage, you can come back to this video and watch me do it. But I was a bit overconfident in the beginning, I must admit. Easy, if you know how Solana works, but maybe you don't know how Solana works and you need to think about it a bit. Watch some other videos that I made. Which one specifically? I don't know. Maybe something on CPI. Spoiler. Maybe something on instruction depth. Or maybe something about CPIs or just some. Yeah, I don't want to give you more hints. You don't need more hints. In fact, do it now. Do it now before I give you hints. Hack it. That's the fun part. I'm telling you, it's the fun part. Yeah. I mean, I haven't tried. Maybe it's not even possible to hack this, but I'm fairly certain that I still managed to get the funds out. But before we get funds out, let's get funds in. Let's transfer 10 Sol back to the vault. So the vault should have some funds again that we can get. Let's see how we can do this. But as I said, you do it yourself first. I'm still fairly certain that I could hack this. And I will try myself in a second. But first I want to know if Claude now thinks this is safe. Looking at it with fresh eyes, you think it's gonna find that I can still exploit that? Maybe I'm wrong. Again, I don't know. But I think I can still exploit that. In fact, I'm very confident that I can still exploit that. I want to see how smart Claude code is. We'll see. This is a learning process. It's puttering. Yeah, we'll see. Spelunky. Verdict. No remaining attack vectors that result in vault fund loss. The program is safe. The combination of the multi-loan fix and Solana transaction atomically covers all cases. You seem very confident. I love this, because that means I'm gonna win. I'll work through every remaining angle systematically. It is checking quite a few things. Discriminator collision inside your program, reentrancy, vault reinitialization. It's looking at a bunch of angles that are fair and where it did a great job in not messing that up. But I still think I can hack this. And now I shall prove to you that Claude is wrong. This program is not safe. I hope I will succeed. I'm having way too much fun with this. Okay. Let's write another program. Did you figure it out yet? Did you have an idea yet? Before you watch me do it, try it yourself. Do you agree with Claude that this is a safe program and that it can't be exploited? You can disagree with me, that's fine. I love that. Again, maybe I'm too confident with this, but here we go. New program. Cargo, init, lib, add Pinocchio with an H. Okay. And again, since we're lazy, we're gonna vibe code some stuff. Completely unrelated. Can you write a Solana program using Pinocchio that will just CPI into another program? It should take all remaining accounts and also forward all the instruction data. Should be easy. Build it. I could do it myself, but I think I'm faster if I let you do it. Do you already know what I'm about to do? Do you get it yet? Or are you still puzzling about this? So, we will take accounts, split the first one, take the matters, build an instruction to that first program account. Yes, great. And the remaining matters we forward through, and the data will be the exact same as I get instruction data. And then we CPI invoke. Sounds great. I take it. Let's go. I build it myself. Oh, nope. CPI in root. Okay, you build it and fix it. Now you understand? CPI is behind a feature flag. Oh no! I'm running out of credits here. Let's see what it does here. It's not so difficult. You just build a CPI. I'll do it myself if you don't manage. You need Pinocchio with features CPI. Okay. That's it? Nope. You will also do something else. I'll just accept this. And to save credits, I'm just gonna run this myself. Why do I need to do it with Pinocchio? That just makes it more difficult. I'm gonna fix this myself to save credits. So it builds whatever it changed here. Not so important that we know as a hacker what that actually does, like how it actually works, as long as it does the thing that I want to do, which is do a CPI. Okay, let's test this. Just this program. Let me deploy. Oh, wait. We're missing the classic that I always miss. This. Always missing this. Then let's try again. Yeah, better. Okay, cool. Solana, program, deploy, target, deploy, exploit. Let's go. We deployed the exploit. Let's see if that works. Let's do an instruction to this program, this exploit program, and it will need accounts. The first one is which program to call. Gonna be calling the no-op program for start. So account number 1, have the no-op program as a read-only, just read-only. It's a program. That's it. You don't need any more accounts for now. And you don't need any data for now. But actually, it's just so we see if that will be passed through. 1, 2, 3. Just so we see if that works. Okay, so now basically it's just testing my CPI program with this CPI script. And yeah, seems to work. We call our program that does in fact CPI into the no-op program. And if it would load instruction data, come on guys, the Explorer used to be so snappy and then you implemented features and now it keeps loading that forever. I don't like this. This used to not be a problem. I'm against features if it ruins the default stuff. Maybe it's not even because of features, but what do I know? I just want to see that it took my instruction data. Ah, screw you. So my exploit program with this data calls this program with this data. Wonderful. Does it also do that for accounts? It should. So if I had an additional account, it doesn't matter, I can put my own account. Will it also put that forward into, yeah, there we go. So this one, it manages to load, nice. So this is what I give to my CPI program and it will forward the accounts and the instruction data. Wonderful. Do you see where I'm going with this? Because, and now I'm gonna spoil you my idea. Again, I'm not sure if that will work, but I'm fairly confident that it will work. My idea is that this Flashloan just checks the instruction sysvar for the instructions, and that's the top level instructions of the transaction. It does not check all of the nested instructions that I could do with CPI. So a call to my exploit program will be unnoticed here. And that way I can again take out 2 loans, right? And taking out the loan, it will again check that a repay is present, and that should also then work, also from CPI, I hope. So yeah, we just do the same thing that we did in our exploit with 2 loan instructions, just that one of them we will need to hide in a CPI. So let's do that. Exploit with CPI. So my big loan, this one, I need to hide in such a loan through CPI, where we call our exploit. And then basically I'm just going to do this. I'm just going to do the big loan. Then here I'm going to put the big loan program address as a read-only. And then I'm going to put the big loan accounts. I'll just flatten them into here. And the data I will also directly pass through the big loan data. And that way it should just hide all of that into the CPI. And then I put, let's do maybe first the small loan, then the CPI, and then the repay. And I'm gonna take 10 sol, and I'm really just gonna borrow 1. And this is my attempt for this exploit. You think it's gonna work? I think so. Yeah, I'm like 90% confident that this is gonna work. Come on, you got this. I'm a hacker. Let's exploit this with CPI, and damn it! Multiple loans not allowed. Oh shit. It is smart enough to get that that's a flash loan? Does flatten the instructions? Damn. Well, maybe AI is smarter than me. That sucks. I was so confident. But yeah, does the instruction sysvar contain the flattened instructions? Probably. Damn it. This is disappointing, but also good. In a way, this is really good. Because that means AI is correct, that means that it's not making massive errors like I thought it would. Which means, hey, maybe AIs are just the smarter devs. Why do you watch my videos? I don't know. To still learn stuff? Okay, what can we learn? This instruction at the instruction sysvar probably actually is the flattened instructions. Yeah, I can't hide them. Shit. So if you said AI is correct and you didn't believe me, good. Good for you. I actually thought that that was possible to hack this. Maybe I find another angle to exploit this. Can the CPI hide the instruction? Boop. Boop it. Yes, CPIs are invisible instruction sysva. The sysva only contains top-level transaction instructions. A CPI call into Flashloan does not appear there at all. But that is telling me that it's supposed to be able to do this. Do I have a misconception about how the sysva works? Ask another AI. It does not include nested inner instructions. It only includes top-level instructions submitted in the transaction message. That's what I imagined. But then I should be able to hide my loan instruction, no? A call to program B is not visible in the instruction sysva. Let's look at the logic again. Maybe my problem is that I'm having the same discriminator here, but I shouldn't have the same program. And you are checking specifically for if the program ID matches and the discriminator matches. So already here the program ID should not match. The instruction sysva provides access to the serialized instruction data for a currently running transaction. It allows for instruction introspection. You know what? I'm gonna add some logging to this because I thought it's just top level. Maybe it's not. Let's see what it matches here. So if we have an instruction, can you log, well, what do we get? Index, program, and maybe instruction data. Anchor build, anchor deploy. Okay, now back to my exploit. Let's see. In the Flashloan, you find instruction 0 is to the flash loss program with that data. Then 1 is this. And yeah, it seems, no. And then instruction 2. So the first one doesn't find the second Flashloan. Oh, but then, oh, of course. But then the other one, shit. Yeah, then the other one, obviously, the one that I'm calling through CPI, that one finds the first one and says multiple loans not allowed. Oh, yeah. That's what I wasn't considering. Shit. So my assumption that I can hide this through a CPI is correct. The first Flashloan doesn't find the second Flashloan, but the second Flashloan knows that it is itself a Flashloan and finds the first one. Dang it! That's my issue. And if I would hide them both through CPI, then I would have the problem that the repay doesn't find it, and then it also doesn't work. Shit, damn it, that program can't be hacked so easily. I really thought it would be more easy. Yeah, I wasn't considering that. Damn it, AI was smarter than me. Wait, why does it say multiple loans not allowed? What is it actually really checking? Multiple loans not allowed we get if the index is not the current index. So we find a loan and we're not currently in this index. That's so smart. Because we're already one top level instruction further. Smart job, Claude, smart job. I can hide both of them, but then my repay will be unhappy. Because my repay expects one to be at top level with this program ID. So the logic essentially says, if we find a loan that is not us. Yeah, it's a smarter implementation than I thought. Damn. But hey, that's a good thing. That means AI is really good at programming Solana programs, better than me, because I would have messed this up, most likely. Does it mean you should only vibe code anymore? Is that what I'm saying? Not really. Damn. Yeah, I thought I could get around this. I can't. If it wouldn't check the index, then I could do it. Since they're both loading the same way, yeah, there's no way around this. Okay, hold on. What I could do is check there's no double loan in the replay. Let's see what Cloud would suggest. That's a good idea, but it might be too obvious. But actually, let's do that. Let's introduce a bug just to mess with the Git, because I want to give you something that you can hack, or that you could hack in the past. In the repay, we're gonna default to this, and we're gonna remove this, and then we're gonna git commit. Oh no, I introduced a bug. And then we're gonna fix the bug. Okay. putting it back. And then also, damn it, I hit the limit. Okay, I guess I gotta do programming myself. Fine. It's better because it introduces more errors anyway. So I'm gonna say, yeah, great. This is such that you have something to exploit. I'm gonna just search for the repay. We take it out of here, and therefore in the repay, we treat that part. If it is some, then we return that error. Fine. So this way, we're still enforcing that there can't be multiple loans, because if we already found a loan amount between 0 and the current index, if multiple exist, error. Yeah, fixed it. Okay, fixed the bug. Now try to hack this. There we go. So let's hack this. That's what I'm gonna give you to hack, because otherwise you might get frustrated that you can't, because Claude is too good and I'm too bad. Yeah, I take that on me. I made a mistake. I thought that I could hack this. I couldn't. So now I introduced another bug for you. Hehe. Let's anchor build. Should have done cleanup, lol. Nobody will be suspicious about anything here. Okay, anyway, we were at anchor build and anchor deploy. Good. So our regular exploit with trying to get out some sol with 2 loans should still not work. There we go. We're getting multiple loans not allowed. We made a fix for that. But with our current more exploitable version that I gave for you to exploit, we should be able to do this thing with a CPI, because now the loan itself is not checking for the multiple loans. It's the repay that is checking for double loans, and the double loan is hidden in the CPI. Let's see if this way we can actually get those 10 sol out. Exploit with CPI. Yep, that worked now. This time I could get 10 sol out of the vault because I did a regular loan and then one through a CPI, such that it is not visible to this repay instruction. Nice. That's how it works in the end with this hidden Flashloan. Okay, good. And if you found that exploit, congratulations. Very well done. You are smart. Really, this was about practicing how we can exploit that stuff and seeing how we can write secure programs, which Claude actually did really well. Like, I am impressed by how well it did. And if I wasn't rate limited now, I would let it analyze the current program and tell me if I can exploit it, which I'm pretty sure it would be able to tell me that yes, I can. But I gotta wait 2 more hours. So, we did see that Claude is pretty good at writing anchor programs, like surprisingly good. It basically wrote the entire thing in one go, didn't need to fix much, and also protected pretty well from exploits. Just the first time I had to tell it to make sure that I can't exploit it, but then it fixed it pretty well. And we learned something about the instruction sysvar and tried out some hacking ourselves. So I think that's a win. Even though I totally got that wrong. I totally underestimated how well this was implemented. That's on me. Now it's on you. I'm gonna transfer that 10 sol back to this account. This account has its 10 sol back now. Feel free to exploit it and grab those 10 sol. It's just definite sol, but it's 10 sol. It's about the learning, not about the sol, right? Because if you learned that, then you can exploit other programs on mainnet that have sol, right? Or you just write secure programs for yourself. That's what you're here for, right? Not for exploiting others, right? We don't want to hack other people's contracts. We want to create safe ones ourselves, is my reasoning for making this. But the real reason is, I just want to have fun. And I had. Even though, admittedly, I was wrong at parts. Claude outsmarted me. On the one hand, that's a good thing, because it's writing secure code. On the other hand, it's also crazy that AI is so good at that already. Because that also means AI can hack programs, which means you can use it for good or for bad. But yeah, it's pretty impressive what those AI models can do. And I think using them is the right strategy. Because again, they outsmarted me. But still, I think it was a fun challenge today. I hope you learned something. Let me know how you did and how fun that was and if I should do such a challenge again. Cause I just love to hack and I hope you do too. I'll see you in the next one. Here's some more videos and challenges. Subscribe if you haven't already. If you enjoyed this challenge, give me a like and I will see you in the next one. Till then, bye bye. And hack that program. Oh, you create a hackers challenge for me. Yes, please do that. If you have something fun, a program for me to hack, let me know and your challenge might be featured in an upcoming video. Cause I just love to hack. See you next time.